So suppose that you're standing on some fishing dock, and of course, there's all this water over here. And you're trying to catch some fish. Now, you have some rod, and you cast it out into the sea. Here's the thing. Let's say that the fish was, from your point of view. Well, let's say that the fish was right here. Okay. Now, from your perspective, well, yeah, you're going to aim at this fish and you're going to throw it right at the fish. Let's say you had 100% accuracy. The question is, well, are you going to actually catch the fish? And the answer is no, according to physics. Because what's happening here is that let's say you aim at the fish and it hits the water. Well, assuming that there's some imaginary normal line, this is actually going to not go directly to the fish, but it's going to slightly refract. And it's going to bend a little bit. So here's a better example. So let's say you have this side right here is entirely glass and this left side is entirely air, and a beam of light is shot at this little thing here, this little line. This is a beam of light. Now, when it passes through, what's going to happen here is that, okay, well, the glass, once it enters this substance, it's not going to go straight here. It's actually going to bend a little bit. It's going to bend like this. Okay, hopefully you guys see what I mean. And what we call this is refraction. And here's what you need to essentially know about this concept. This right here is called the angle of incidence. Why? Well, it's relative to the normal. The normal means perpendicular essentially, and this is that perpendicular line. So relative to normal on the other side is this, the angle of refraction. Because when you enter a different substance with a different index of refraction, well, you're going to see is that you're actually going to have things bend a little bit. A great analogy here is imagine you're driving a car, right? A car has two sides of wheels, and this is this car. Now, which of these two lines are going to hit the normal line first? Well, it's going to be this guy. So the bottom ray is going to hit first, and so you can imagine if they're both going this way, if this is hit first, this dotted line here, well, the car is going to now start shifting like this, right? Because the wheel is still here, but this part touches the line first. So it's going to turn this way a little bit. So it's going to go like this, and then it's going to go turn like that. That's a great way to think about it. So now the question here is, well, let's say you do have this line here, and you go from some substance, let's say air, to glass. I want to know, well, if I'm going at this angle here, whatever this angle might be, this angle of incidence, and let's say it's theta I want to know by how much does this refract? So I want to know this angle. And that's where we use Snell's law. Snell's law states that there's an index of refraction here. N1 sine theta 1 is equal to N2 sine theta 2. In this case, we're really saying that n1 sine theta I is equal to n2 sine theta r. And we can use this formula given 3 out of the 4 things to figure everything out. So in this case, some things you're going to be you're not going to have to know here is what this n1 and n2 are. These you're going to either be given or you're just going to have to memorize them. Just know the important ones are for air, n is equal to 1, for water, n is equal to 1.33, and for glass, n is equal to 1.5. Just keep these in mind and remember Snell's law. Okay. So you can imagine here some problems here. So taking that case right here, let's say I have some angle here, and let's say this is 30 degrees. I want to know how much it refracts, so I'm looking for this angle right here. And this substance here is water, and this substance here is air. So using Snell's law, how can we find that angle? Well, we're going to call this n1 and this n2. So n1 sine theta 1 is equal to n2 sine theta 2. Plug in what we know, the index of refraction here is going to be 1, so it's just 1 times sine of 30 degrees is equal to index of refraction is 1.33 for water, and that's just going to be multiplied to sine of theta r. Be consistent with these guys, don't mess up. From here, sine of theta r is just the sine of 30 degrees divided by 1.33. So theta r is the inverse sine of sine of 30 degrees divided by 1.33. What you would do here is use a calculator now. So let's quickly do that. Go to degree mode. And we should get 22.08 degrees as our answer. So the idea is that when you have, all of these things, you're just going to set it up. It's always going to be a setup-based problem, not a lot of thought that needs to go in here. So this is the basics of Snell's law. Now, something else we haven't talked about here are what critical angles are and other cases of total internal reflection. But, well, those are going to be for a different video. This is the general idea of Snell's law, and I hope you enjoyed watching it. See you guys in the next video.